Hi guys, look at here. So we have to today see JVM architecture with garbage collection and what is the Java architecture. And we'll see some basic concept of the JVM and what is the JVM architecture also. And then we'll see garbage collections and field, I can say finalizer methods. So here we'll see all these things. And there are a number of examples I have prepared on garbage collections that we'll cover here. And then look at here. So so first of all, if we talk about the Java architecture, what is the Java architecture, what we do in Java? So if you can understand, it is very easy to understand the Java architecture. So there are basically some components. I mean, there are four components of Java architecture. So first is the Java programmings, and that Java programs we use oops concept in that first things, right? And then what we do, we compile it, right? So after compilation we get a class file, so that is a class file format. And Java API, when we run the programs, so it take usage of Java API. So there are a number of inbuilt Java classes which we have used in our program. And finally, that program interact with the JVM and JVM interact with the platform, right? I mean your OS. So this is a Java architecture. So look at your class file format is a binary code, makes the Java file network mobile and platform independent, is compact and can be transported easily and quickly. So and next is the Java API, if we can say here. So look at this Java API. What is Java API? So Java API is nothing but a set of class interfaces that comes with the JDK. So when we install JDK, if you remember, JDK is what Java tools plus GR is. GR is again what it is a Java API plus JVM, right? So that API is having some number of classes and number of interfaces, annotation in form of package. So it is actually a huge collection of library routines that perform basic programming tasks such as looping, displaying GUI forms, etc. and all. In the Java API, class and interface are packaged in packages. So we import package and we use some classes from that package. All these classes are written in Java programming language and runs on the JVM. So Java classes are platform independent, right? As we know, Java is platform independent. So but JVM is not platform independent. You will find different downloads for each operating system. So JVM varies OS to OS. If you're downloading for Windows, it is different. For Linux, it is different. For uh, Mac, it is different. So it is having different JVM. In other words, Java API ready-made Java classes provided by Java to help programmers write Java code. So let us say you want to use system class, you want to string. These are what? It's a kind of Java API, right? And next, JVM. What happened in this here? So whenever we run the program, JVM come into the picture and it loads some classes from the some loader. Okay. So JVM is the heart of Java, and it is a software that interprets and execute the bytecode. Starts the application by running the main method. Is responsible for loading .class file through various class loaders. Okay, so we are having certain loaders now which help us to load the class. So JVM class loaders can be classified as pyramidal class loader. So we are having here two: pyramidal class loader and class loader object. This guy helps initially to load some API class when the program executed. Now another is the class loader object. What this guys does, if you are running your program and during runtime, if you need some classes, so this guy will load to your application. So if you can see this image here, it's, look at this here. So you are having a program and that is written in the class file. So your code is here. Now there is some API exist where it is. If you open the lib folder of JRE, you will get one file that is rt.jar. This jar file rt.jar is having all the dot class file, all the interfaces we are having in the dot class format here. Okay. Whenever you are writing some program and compiling and running, so class loader comes into the picture, and this class loader loads the classes from here and bring to here. So it will come to execution engine, and that execution engine will interact with your native machine. Okay. If you can see the pictures in details here, look it now. Yeah, this is only, I think, yeah. So you you might have understood this concept now. What is a platform independence here? Is gained through the bytecode obtained after compilation. So that dot class file gives us platform independence because that class file can be executed on any kind of platform now. So thus reducing time and cost. So and support is spread across all four components of Java architecture. As I said, it is a Java language, and then class file format, JVM, and Java API. So these all four are the uh, components of Java architecture, and that independent support is all throughout. Next is the security. The security concern comes once you are connecting your system with some other or out of the world of this system, right? So let us say you are accessing some internet and all. In that case, there is a chance to get virus and all. Now consider you are loading some Java file. Then in that case, whether you should worry or not, it could be affected from virus or not. So we can see here, as we know, there are four types of Java program. So application, applet, and package and sublet. So if you are downloading applets from internet, I mean if you're opening a page and that page is containing applets, so and that applets may be untrusted, may be affected from the virus, then that applet will run in very secure environment. It is not going to corrupt your systems, so you need not to worry when applet is downloading or loading in your system, because untrusted applet cannot read or write to your local files. It is not going to access your local files of your machine, of your hard disk. So your hard disk and all, it is safe. So it cannot make a network connection to any other machine except from which it was downloaded. And let us say you are having in a network, means let us say your computer is having another 100 computers in the network. So applets will not understand the rest one, it will just look your system only. So whole network is safe at this place, right? Now it cannot load any new dynamic link library. So there's a concept of a DLL file, .dll file, which help us to initiate some process. So this DLL file is not going to load by upload, so it is safe. And this uploads I mean this applets cannot call native methods. Okay, so it is not going to call a methods from your machine, so your machine is safe, right? Now how it does this much? So there's a concept of here, look at here. Whenever applets load, it loads into the very secure environment and it creates a separate memory, and that memory is called Java sandbox. Okay, so it runs in that Java sandbox, and lot of verification has been applied on that bytecode. So there's a bytecode verifier, applet class loader, and security manager. So bytecode verifier does what? It checks the structure of the class file, validity of classes, variables, and methods used in the program. And then let us say, as I said, there is some class loader which help us to load classes from APIs, right? Now in that case, if we are loading applet, from where it will load? Because it cannot access your local machine. So there's one applet class loader which help us to load classes. From where it will load? It will load from the server from wherever you are like accessing. So it will request from the HTTP server that give me that class file, and then it will work only. Next, security manager defines the boundaries of sandbox. So the Java API refers to the security manager before it allows access to any resources. So even I explained before, like there's some security manager API in Java which help us to set some security, and so we need not to do any programs and all. That's set security manager method is there which help us to set security.